Welcome to this video, which demonstrates Adacore's new QGen code generator and model verification tools support for multiple versions of Simulink. A single version of QGen can support code generation for versions of Simulink from 2008B through 2016A. This provides additional value to users of the QGen code generator, and we'll give a short demonstration of how that works. Just a little quick summary of QGen's capabilities. QGen is a code generator that can generate either Misra C code or the Spark Ada subset, both languages oriented towards building safety-critical applications. QGen is integrated directly in the MATLAB IDE, making it easy for the programmer to view their model, develop their model, and then try generating code for some or all of the model. But QGen is also designed to operate from the command line after you've saved your model, either in the MDL or SLX format, as well as some information about the workspace and the types of the intermediate types within the model. QGen can then operate independently of MATLAB for generating code, and at that point you can change the options and so on without having to re-enter the MATLAB IDE. So here's a typical model, and we'll actually have an example of this, pretty much the same model. QGen, there's a menu which you can see perhaps here where it says QGen is just one additional menu added to the Simulink IDE when you're viewing the model. And with that menu, you can choose code generation and model verification options and so on. So QGen has a number of different modes for generating code, and there's a standard model which by default creates a separate source file for every atomic subsystem, and variables tend to be represented as global variables in appropriate Ada or C code that you generated. Alternatively, if you wish to minimize the number of source files, you can essentially inline all of the subsystems into one file, in which case the code is the sort of least amount of code, and there might be less memory consumption, less copying, and so on, more optimization opportunities. Alternatively, if you have a number of subsystems, let's say in the library that you reuse multiple times, and you don't want to have multiple copies of the code for those subsystems repeated throughout the larger model, QGen has a mode for generating reusable code, analogous to that provided by Simulink, and it will then pass parameters rather than using global variables for representing persistent state and input-output signals and so on. So the thing we're going to be talking about today, however, is QGen's support for multiple versions of Simulink. As I mentioned at the beginning, QGen, a single version of QGen, including the current version, supports Simulink versions 2008B all the way up through 2016A. So that's like 16 or 17 different versions of the Simulink tool. It can import models that were saved earlier in any version of from 2008 beyond, and yet it generates code that's consistent across all versions. Now there are differences occasionally in the Simulink semantics in terms of ordering and so on, but it deals with those and it tries to generate code that is consistent. Let me just sort of imagine a scenario here. So suppose you were using Simulink 2008B for many years and building and testing and so on, but at some point you decide it is time to upgrade. You may want to start using new versions, new features of Simulink and so on, and suppose you decide to upgrade to Simulink R2015B, let's say. If you're using other code generators, then you might have to upgrade your code generator as well, because they tend to be locked to a particular version of Simulink. At that point, although the model itself hasn't really changed, it is possible that you might be forced to use a new code generator that might do things rather differently. It might have been 7 years or whatever since you last upgraded your code generator, and during that time there might have been significant development on the code generator, producing potentially significantly different source code. And certainly in some environments, if the source code is dramatically changed, that might mean you have to go back to retesting much of the code that's generated. So QGen provides an alternate path to accomplish similar things. Because QGen is designed to support multiple versions of Simulink, rather than having to get a new version of the code generator for each version of Simulink, you can stay with just one version and nevertheless move from an older, let's say, to a newer version of Simulink, or for that matter, even move backwards if you've got some problem with the later version of Simulink. And it is conceivable that some of the semantics might change. For example, there might be a difference in the way Simulink does block ordering, or the implied data types of certain blocks and certain signals. But that's generally pretty minor. The more significant change typically comes from the changes to the code generator, which you're avoiding. The code generator might have different naming conventions, different optimization strategies, different packaging approaches, and so on. So it can be disruptive. QGen, we have the same code generator, and we will generate code that is essentially very much the same. It would only be if the ordering were changed by Simulink, then that would be reflected in the code. But the actual patterns used for generating the code, the packaging, the naming, and so on would be identical. So we'll, in this coming up little demo, we'll look at a model that was originally saved in 2008B, and we'll look at the same model that is being now manipulated using Simulink 2015B. And we'll show how QGen can import the old model that was saved earlier, and it can also operate as a plugin in the new version of Simulink, and can also generate code from that. And we'll look at how the code differs and so on. Okay, so and just to finish this slide here, as I mentioned, QGen can be a plugin, or it can be a command on the command line. And the command line has some advantages in terms of not having to restart MATLAB and Simulink, and you can alter the code generation parameters and options and so on to tune the way you get the code out without having to re-invoke Simulink. Okay, so now we're going to move over to Simulink. I'm going to quickly switch to the model that we've loaded. This is a simple model. It's a PID controller, and it has a virtual subsystem here, which is a simple filter. And then here is the PID controller proper, which is marked as an atomic subsystem, and it has within it another atomic subsystem, which is a derivator. And so it's a relatively simple model. And as I mentioned, we have this QGen menu here. We're going to be building some code from this. And we're going to choose C code, and otherwise we'll just be the default. So now I'm going to generate the code, and this shouldn't take very long. Down here we can see what's happening. And now we're done. Let's take a look over to the MATLAB window. We see here that it's generated some code. Here's the C code. We can take a look at the C code, for example. And this is the top-level model itself. We have some traceability information in here about what Simulink blocks were used to produce this piece of code. And if we drill down into the particular PID controller itself, we'll see additional source code. You can look at other videos that we've put up about QGen where we go into the details of the code generation strategies. But here what I'm really trying to illustrate is that this is the result of using Simulink 2015B, and QGen as integrated has no problem manipulating this model. Here's the model that we saved. Now I'm going to do the same piece of code generation, but I'm going to do the work based on a model that was saved earlier when we were running 2008B version. One of the things that we show in the command line is exactly what command was used to compile the code. And if we scroll over, we can see that it's executing the QGen-C, our QGen code generator, and it's got various parameters and so on. And here is the saved model, controller 4.mdl. Here is some information that was saved that records the types of the signals at various points within the model. And this tells it where it will be putting the code and so on. And here is some workspace information. If there were variables in the workspace, we can look at what this contains, and in this case the workspace is empty. But you can have models that depend on the contents of workspaces, so we do record that and we save it for the QGen code generator. This is the other piece of information that the QGen code generator looks at, and it is it's a fairly large file. It records the types of each of the inputs and outputs. So here we have an in-data port that's of type double and so on. This information is not directly represented in the MDL file, and so we extract it from Simulink and save it in a file to ensure that QGen generates code that is perfectly consistent with the order and the types that are used during simulation, because you'd like your simulation and your generated code to have identical properties. Okay, so now what we're going to do is we're going to, so we've got this code, here it is, and we're now going to generate code using a script. And I'm actually going to comment out this first piece because we don't want to regenerate code for that. And so let's insert a comment here, and we'll say this. We're not generating code for that. But we are going to generate the code from the 2008B model. And so I've essentially copied the line that was in the Simulink command window output there. And this should look very familiar, same number of, same amount of parameters and so on. The only difference is that now I'm using a 2008B version of the model, which I saved earlier when I was running Simulink 2008B. But I'm otherwise using essentially the same types information, and I didn't actually have to give it the workspace because, as we saw, the workspace was empty, so I eliminated that. And I'm going to save the output in this different directory so we can distinguish the two and compare them. Okay, so now we're ready to run this file. It's called qgenc.sh, and here we go. And so it was not generating code from the 2015B model, but it did generate code from the 2008 beta model. And here we have the output from that process. And if we look around here, we will see that we have controller 2008B MDL generated. This I had generated earlier. The other piece that was just generated just now was over, let's see, where is that? I think it's in the next directory. Anyway, here is the code for the 2008 model. And if we go into that directory, we can see what it contains in it. So it's the same information controller 4.c, derivator.c, and so on. If we look at this code, we'll see what it looks like, for example, and it should look familiar. It looks very similar to what the code was that we generated for the 2015 B model. And we'll go down to, where is it? Oh, right, version 2015, type 15P, no label. And there we have the output that we just generated, controller 4.mdl generated. And if we look at what's in there, there we see the same thing. So the question is, how does this code compare? And if we are do some a diff between everything in this directory and everything in the other directory where we had the output from our 2008 code generation. We will see that the differences are essentially in the comments and a few other things, but otherwise the code is essentially identical. So here's where we do our difference, and we're seeing differences in some of the comments, the exact location of the directories where we generated, where the model came from and so on is recorded in comments, so that's useful for historical purposes. But as you can see, that's the only difference. We're not seeing any difference in the code generated. Now, it is possible there might be differences if the two versions of Simulink chose different orderings or different types, but that's relatively rare, and it would have relatively minor effects on the code generation, so you could easily see what they are using diff or other tools, and know that those are changes that are actual semantic changes that are due to Simulink changes. They're not due to just changes in the code generator. We believe that this ability to operate with multiple versions can provide a lot of value to customers who do relatively rare upgrades, that they stick with one version of Simulink for perhaps many years and then do an upgrade, and would rather not have to also switch to a new code generator at that moment. And they would rather stick with the same code generator so that they are not paying a heavy price for moving to a code generator with significantly different output produced. Thank you very much.